Okay, so now that we figured out what polynomials actually are, polynomials could be, binomials or monomials or trinomials. We're going to add them now, all right? So before we, for example, we'll get into the adding first. So we'll teach us as two separate sections. So I'm going to take this linear binomial, right, 4x plus 3, and I'm going to add it to this linear binomial. Okay? So 4x plus 3 is being added in with 5x minus 8. And the main thing here is that when there is a plus sign in the middle, those parentheses don't really mean anything. The only reason I put them there is to show you that I'm adding a 4x plus 3 to a 5x minus 8. You're not going to ever do this. You don't have to do this. But if you have a 4x plus 3 and a 5x minus 8, if I were to give it to you like this, what would you do? You would just combine like terms, right? Wouldn't you just say, well, 4x plus 5x is 9x, and a positive 3 and a negative 8 is a negative 5, right? And that's exactly what you do with the parentheses too. It's just saying I'm taking this binomial and adding this binomial to it. So when there's a plus sign there, basically you just combine like terms. And you can pretend like that isn't even there, and you could take them out if you want. You shouldn't really need to, okay? Even if the question was this, negative 3 plus 2x, negative 3 plus 2x, I don't want to get to that yet, plus 8 minus 7x, okay? Here's a big hint for you. We always want to show as little steps as possible, right? That's kind of what we want to do. So I know that the constants are first, but yesterday I taught you standard form. And your answers from this point on out should be written in standard form, meaning highest exponent to lowest, constants at the end. So why do it in the order that they appear and then switch your answer around? Can't you just look for the highest exponent and do it first and then write it first? So I know these are first, but I'm going to do my x's because I have a 2x that's positive, a 7x that's negative, so I'm going to have a 5x that's negative, and I wrote it first because I don't want to do the answer and then have to move it around. That would be a wasted step. Negative 3, positive 5, or positive 8. Good? Good so far? Okay, so that's really as simple as it starts, okay? So before we go and make it a little trickier, we have to talk about this. When I first started combining like terms yesterday with my 7th graders, they're learning combining like terms for the first time. How cute. Do you remember that? Right? So then I said, here's 4 pink centimeter cubes, and here's 2 more pink centimeter cubes. So what do I have when I put them all together? And they were like looking at me like, this is so easy. We learned this in like 1st grade. Yes, you have 6 pink centimeter cubes, right? I mean, that's all that there is to it. So what might make this look weird to you? And for some reason, you just came off of 3 full weeks of exponent rules, right? And you're looking at this thinking, no big deal. 4p plus 2p is 6p. But if I asked you to multiply 4p times 2p, you need to remember to make it 8p what? Squared, okay? So you're coming off a whole unit of add those exponents, add those exponents, add those exponents, right? Now I'm switching over and I'm going to ask you to add 4p squared plus 2p squared today, and you're going to be very tempted to make it 6p to the 4th. I know you are, right? Because you have that on your brain. But if I have 4p squareds and I add in 2 more p squareds, they're still p squareds, right? They don't instantly morph into p to the 4th. They are still p squareds. So you have to kind of shift your brain right now and say to yourself, today when we are adding, don't add the exponents. And there's going to be a lot of them because they're polynomials. Okay? So the math people, the math gods kind of decided to mess with you a little bit because you don't add the exponents when you're adding. You add them when you're multiplying. Kind of seems right. So when you're adding, meaning combining like terms, don't add those exponents. That's the most important thing that you need to keep in mind today, is that, okay? So the other thing that you need to know is this. If I have like a 4a to the third, and I ask you to add it to a 3a squared, so we need to kind of, asking you to add this is the same as asking you to add that. And what did you learn a long time ago? Those are not like terms. One is an A and one is an X. And when I taught this concept to my 7th graders yesterday, I asked them to try to add that. I asked them to try to add 4P plus 2G. You don't have 6P. You have 4. You don't have 6G. So they learned that you couldn't really add this together because they weren't the same. Same reason here. Same reason here. I know they both have A's, but this one has 3 and this one has 2. Okay? So the next most important thing for you to know is that these two terms are not like terms and cannot therefore be added, meaning their coefficients cannot. Okay? So in order for you to be able to add the coefficients, their variable part is what they call it, must be identical. A p squared and a p squared, go right ahead. Not an a cubed and an a squared, though. Okay? Those two things, are we good with? Okay? The other crazy thing you're going to see that's new is they're going to give you all kinds of crazy terms to try to add. Like, for example, 4x squared y minus 10x squared y. Are those like terms? Yes, because they both have an x squared and a y. And when I ask you to combine a positive 4 of these and a negative 10 of these, I'm going to have a negative 6 of these, right? Yes? Boy, is it your brain just instinctively wanting to add those? Yes, I know it is, because I've spent the last 3 weeks pounding that into your brain. But now I'm asking you to kind of forget about it for right now. Okay? So we are moving on to adding them, which means we don't add the exponents. Okay? So those are some prerequisites before I actually get into doing some actual problems. The last one I want to talk about is this. We're going to see two fraction problems on our sheet today, so we're going to have to kind of remember how to do those. We'll do that when we get to it. Okay, so you have all the information we need to start to do a problem. So if I were to ask you to take 5x squared minus 4x plus 2, which is a second degree, which we call a quadratic, right? Another thing the math gods messed with you on. So the quadratic trinomial, and I'm asking you to add it to this negative 3 plus 7x minus x squared. Okay, got a little cramped there. So I'm looking at it. This one's in standard form, which is nice. This one's all out of order, but it doesn't matter because I'm just going to look for my like terms. First thing I'm going to do is start to look for the highest exponent because I want to save some steps on my paper. I'm going to put my answer in standard form as I do it. These two are like terms, right? I have 5 positive x squareds and 1 negative x squared for a total of 4 positive x squareds. And you know what some people like to do? There's a lot for your eyes to look at, isn't it? You know what they like to do? Done. Done with that. I don't want to look at it anymore. Okay? So then after 2, I'm looking for all the linear exponents. I have 1 here and 1 here. Actually, I have 4 negatives here and 7 positives here. So that's going to give me 3 positive x's. Don't want to look at that or that anymore. And you don't have to do that. Okay, and then I have a negative 3 and a positive 1. So really, once you understand these little tips, the rest is like combining like terms. That's all we're doing today. Subtraction is going to have a little twist on it. But for right now, that's all you're doing with addition. Are you okay with addition so far? Okay. Let's just do another one real quick. All right. You try this one on your own. Let's take negative 8 plus 3x squared and add it to okay, go for it. So I look for 3 is the highest one I see. But I don't see any others in this trinomial to add with it. So what should you do? Yeah, you just kind of bring it down. Okay, I don't want to look at that anymore. Then I look for my squareds, and I have negative 8 here and a positive 3 here for a total of negative 5x squareds. It's easy to forget your x sometimes. Okay, and then a negative 8 and a negative 1 gives me negative 9. Basically, it's integer rules. Are you ready? Okay, so let's talk about what this one would look like. It's not going to look pretty. Yes. But that's okay, because we're in advanced algebra. We can do fractions, right? We learned fractions in 4th grade. Okay? So just a quick little review of fractions. These are my like terms. These are my like terms, okay? So when I do fractions, I kind of like to set them up vertically like this because it's a little easier for, I find, for some of my 7th graders to kind of see that equivalent fraction right next to it. So you know common denominator, right? You can't add fractions. I would never expect anybody ever in this class to tell me that this is just 4/7. Oh my gosh, don't ever, I feel horrible even saying that, right? Okay, that's like a mistake 4th graders would make. Okay, so we're going to multiply this times 3 and get 9. We're going to multiply this by 4 and get 4. And now that they're both 12ths, I can add 4 plus 9, which is 13 twelfths. And if I want to really get fancy, make it 1 and 1/12, right? So I got 1 and 1/12 v squared, and I'm going to do the same thing for my v terms, except let's make this a little fun. Make that a plus. Okay? Okay, yeah, so watch this. So I have a negative 1/2 that I want to add to a positive 7/8. I don't need to change this because 8's going to be my GCF, right? But I do need to change this into 8s, and a half is just 4/8. But that 4 is, the whole fraction rather, is negative. So what do I do when I have negative fractions? I ignore the denominators, and I treat that like a negative 4 and like that like a positive 7. And what's that answer? 3/8, right? Because a negative 4 and a positive 7, subtract, take the sign of the larger. So this is going to be a positive 3/8 v, okay? We're not going to, I don't want you to be held up on those problems, but I just wanted to do a quick little fraction review with you. Okay, ready for subtracting? No? Okay. Subtracting, there is one little twist to it. So when you have a plus sign in the middle, you are good to go. Answer only, no work to show unless it's some fractions, and then you're good. Not the case for subtraction. Little twist on it. So let's talk about what to do in subtraction. So a couple things. If I were to ask you to do this answer, okay? I'm just wanting to do this. Subtract the sum of 2 and 14 from 11. All right. You could do it in your head, and then you can do it, write an expression. So let's just do a little experiment here. So you can get the answer in your head, and then I want you to write an expression that shows your answer and try to get them to match. Meaning, how could you write this as a problem like that? That would result in the answer that you know is correct in your head. So go ahead and just get that answer first. Okay, so we're subtracting the sum. First of all, this word is kind of important. We got to talk about this word from. Let's talk about that. Let's ignore this fancy stuff. What if I asked you to subtract 8 from 10? Is your answer 2 or negative 2? Subtract 8 from 10. So that, yes, because it's 10 minus 8, right? So when I'm subtracting 8 from 10, it means this 8, it goes in the second spot, right? So what answer did you get? I want you to subtract this sum from 11. What is the sum of 14 and 2? 16. And what is that subtracted from 11? Right? Okay. The sum of these two is 16. And I'm taking that sum away from 11. So the answer is negative 5, okay? Was anybody able to create an expression that got me that answer? Because you want to know, what people did. They are taking the sum of 2 and 14. Isn't that the sum of 2 and 14? Isn't that the sum of 2 and 14? And then they're taking it away from 11, right? I'm making a mistake here on purpose to kind of have you notice something. But when you do that problem, you get 9 plus 14, which is 23, not negative 5. So what am I missing? Avery. Right. So by not putting parentheses in, I'm not subtracting the full sum. I'm only subtracting the 2. I need to subtract the sum. Does putting that parenthesis in change my answer? Yes. It says first you have to do 16 and then take that 11 minus 16. Parentheses are a deal breaker. It could give you totally right or wrong answer, okay? So what I'm trying to get you to understand is that, watch this. You would either do it that way, or could you distribute that negative? Could you say 11 minus 2 minus 14? How would that work? That would be 11 plus a negative 16, which is negative 5. So here's what I'm trying to get you to understand. Anytime you subtract more than one term from something, you best put that whole thing in parentheses or your answer will be wrong. Every single time. So if I ask you to subtract 3x minus 8 from 2x plus 1, first you have to know how to set it up. Which one goes where? So I'm taking this away from this. So which goes first? 2x plus 1 plus 1. And look, I'm subtracting the whole expression, not just the 3x. If you don't put the parentheses, you're forgetting to subtract the whole expression. So 3x minus 8. Okay, so let's come back to that for a minute. And let's go over to this. Let's take you back to Mr. Meeks, probably maybe December. And you learned something called the distributive property. And you had negative 5 times x plus 4. Do you remember that? Oh, little baby distributive property problems. Now you do them in like these huge equations. And he taught you to multiply every term in there by that number, didn't he? Negative 5 times x. Negative 5 times positive 4, right? And then you got to one like this. And everybody went, whoa, I don't know what to do. There's no number. It's a negative 1. And what does multiplying by -1 do? Does it change the number itself or just the sign of the number? So that positive x became a negative x, and that positive 7 became a negative 7, right? Or this. This little magic wand here went in and poof, 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 changed everything. So that was a positive 3x, now it's a negative 3x. That was a negative 2, now it's a positive 2. So everything, it's also called taking the opposite of an expression. So if you ever were given this problem and the direction said, take the opposite of this expression, you would just go poof, poof, poof and change everything. Right? Okay? So, leading back to this problem that I have to do, what should I do? So here, you want to know something? Red flag. Remember how I said, like, if there's a negative exponent on the outside of a parenthesis, I would say red flag? This right here is a red flag. It's actually yellow flag right now, but if you were to just do the problem as is and make this 5x minus 7, it'll be wrong. It'll be wrong every time you do that when there's a minus. When it's a plus, you go right ahead. When it's a minus, hold the phone because you have to do something first. So you know what you have to do? You're not really adding a 3x and a 2x. You're adding a 2x and a negative 3x. You're not really taking that one and adding a negative 8 to it. You're adding a positive 8 to it, right? So now, guess what? Remember how I said you don't really like to show your work? That's all you have to do. And you know what? You don't have to rewrite this. Some people like to bring it all the way down so it's all on one line. But then you know what I like to do? Get rid of that. I don't want to look at that anymore because that 3x is a negative and that's supposed to be a positive. Now I treat it like an addition. And now I do 2x plus negative 3x is negative x. And 8 plus 1 is 9. Does that make sense? So for subtraction, you got to make it addition. And didn't Mr. Meeks also teach you that? Didn't he tell you there's no such thing as subtraction? In subtraction, you really add the opposite. So this really isn't r minus s. This is r plus a negative s. That's all I'm doing. Okay? So let's try this next one. Let's do 4x minus 3x squared plus 2. And I want to subtract this whole expression, 5x minus 1 plus 8x squared. So I'm subtracting this trinomial from this trinomial. They're both quadratics because they're second degree. What's that? They're what? They're trinomials, but the highest degree is a 2. So that makes it a quadratic, yep. Okay, so you know what I'm going to do first? I'm going to change this first. So that's a negative. And here's another reason why if you get confused. Because a negative times a negative is a positive. A negative times a positive is a negative. You could look at it either way you want. So now just get to adding, and then you're done. For actually, I'm going to go in, alphabetical order, in standard form. So I'll be tempted to do this first, but I don't want to write the answer and then have to move it around. Just move it around as you're doing it. I have 8 negative x squareds and 3 negative x squareds for a total of 11 negative x squareds. So I don't want to look at that or that anymore. You don't have to write that, cross it out. Now I'm going to look at my first degree terms, my linear terms. So 4x and a negative 5x is negative x. And then all I have left are my constants, which is a positive 2 and a positive 1, which is a positive 3. Do you understand subtraction? That's all there is to it. Adding and subtracting. So if you distribute